As we get started with our CCNP switch course, and we are going to start with VLANs, VTP, and trunking, and those are subjects that are very familiar to those of you who recently earned your CCNA, particularly, I should say, for those of you who earned your CCNA, because if it's been a couple of years since you got your NA and then you decided to get your NP, congratulations, I think that's a fantastic decision. The thing is, though, if you just got your NA recently, you might look at the beginning of this course or my book and just say, okay, you got VLANs, you got VTP, you got trunking, I already know that stuff, watch a couple of videos and then skip to sections with things like multi-layer switching that perhaps you haven't been exposed to yet. Now, I love a confident student. That's what being a bulldog is all about, but you don't want to be overconfident to the point of breezing through or skipping the VLAN and the VTP and the trunking material. Because for one thing, VLANs and trunking, they're the core of your switching network. You're not going to go anywhere in today's world and not need to know something about VLANs. Also, they're going to be all over your switch exam. And why are we in the exam room? Why are we there? We're there to score points, not give them away. And part of having that attitude and taking the points is absolutely mastering the fundamentals to where you barely even have to think about it in the exam room. All of this is automatic because you don't pass the exam when you take it. You pass the exam when you're prepping for it. Now, with that in mind, let's go ahead and jump to the most fundamental of fundamentals by answering a couple simple questions. Why don't we just use physical local area networks? Why do we need virtual LANs to begin with? Well, one reason is to limit the scope of our old pal slash nemesis slash frenemy, the broadcast. Because by default, a switch is going to take an incoming broadcast and send a copy of said broadcast out every single port on the switch, repeat after me or with me, except the port that it came in on. The port that received the original broadcast is not going to send a copy back out that same port. Now, in the example I'm going to show you in a moment, the switch is going to take a broadcast sent by any of the hosts and it'll send a copy of it to every other host connected to the switch. Now, for clarity, I'm not going to show the cables here, but at this point, our hosts are all in one broadcast domain, and this is what we call a flat network topology. Now, right now, they are all in a VLAN, and I'm going to hit you with this a couple times in the first couple of videos. Even if you think you're not using VLANs on a Cisco switch, you are, because by default, every port is in VLAN 1. But we have a single broadcast domain. And again, the term flat network topology, I don't see it a lot outside of Cisco documentation, but it is a good term to be familiar with. Now, I pride myself on presenting as many real-world network examples as I can in my books, courses, videos, practice exams. Rest assured that this is not one of them. Now, broadcast propagation would not be a huge deal in a 5-host network. But of course, how many 5-host networks do we really run into in today's world? If you've got a switch with even 12 ports could be an issue, but then 24 ports, 48 ports, over 60, 96 port switches, that broadcast flooding will start to have an impact on your overall switch operation. It's also going to unnecessarily suck up some of our bandwidth. And I say unnecessary because it's highly doubtful that every other host connected to your switch actually needs the frame that's being broadcast. Let's say we have a 96 port switch and they're all in the same VLAN. They're all in the same broadcast domain. The chances of all other 95 hosts needing a copy of a broadcast sent by any one host connected to that switch, that's pretty low. And that's a lot of extra work for the switch. So we really want to avoid that, of course, at all costs. Now, we can limit the overall number of broadcasts on our network by limiting their scope, which is a fancy way of saying let's only send the broadcasts where they need to go rather than just sending them everywhere. Because what are our three major kinds of traffic? We've got a unicast, which is destined for one host. We have a multicast, destined for a group of hosts. And then we've got a broadcast, which is just destined for everybody we can get it to. And that's not something we really want to do on our switches. Now, what we're going to do to limit that scope of the broadcast is create VLANs. And when you create VLANs, you're also creating multiple smaller broadcast domains, which in turn lowers the number of overall broadcasts. Now, that sounds really odd at first. I remember when I was studying for my NA, and yes, they did have books then, and they were made of papyrus, but that's okay. Um, and the thing was, when I would read that, I thought, well, if we want fewer broadcasts, why are we creating more broadcast domains? But by splitting one broadcast domain into smaller ones, then we're going to limit the scope of the broadcast, because when you have more than one VLAN, broadcasts are only going to be forwarded to hosts that are in the same VLAN as the original sender of the broadcast. I've had people come back to me who ran very simple networks, and they didn't do a lot of fine tuning with it, and they would come back, especially when I was teaching this course live. I'd have people come back and say, hey, we started looking at this VLAN thing and implemented it, and all of a sudden, we had our switch was actually working a little better because we didn't have as many broadcasts to handle. Now, there is no official restriction as to which ports can be put into a particular VLAN, but Cisco's best practice is to have one VLAN per IP subnet. Occasionally in your studies and in your career, you're going to run into Cisco best practices that may not be a best practice for your network, but this is a best practice that works really well in the real world. Now, Cisco also recommends that a VLAN not reach beyond the distribution layer in its three-layer switching model. You saw that in your NA studies. You had the access layer outside, which is the layer closest to the end users. Then you had your distribution layer, then the core layer. We're going to go over that switching model and design, which is why we're not really going into huge detail now. But I just want to mention that we want to keep everything off that core layer that we can. So this is part of that. The Cisco recommends a VLAN not reach beyond the distribution layer in its three-layer switching model. We will go over that in the design section of this course. Now, of course, that brings up another question. How does a port know what VLAN it's in if we're changing that default? And again, every port on a Cisco switch is going to be in VLAN 1 by default. Now, the method that's used to determine a host's VLAN membership depends on which kind of VLAN you're using. Now, in this course and on your switch exam, we're going to concentrate on what we call static VLANs. And static VLAN membership is dependent on the port that it's connected to. So we're going to go in, we're going to configure a little bit of information on that port, and that's how the host gets its VLAN membership. Now, in contrast, with a dynamic VLAN, the membership depends on the host device's MAC address. So again, the static VLAN membership, it's really port-based, but the dynamic VLAN membership is address-based. Now, the actual determination of the VLAN membership is still done by the switch. In both of these cases, almost 100% of the time, I have to throw that almost in there, but almost 100% of the time, the entire VLAN membership deal, it's all on the switch. The host doesn't know about it, the host doesn't need to be configured for it, and what's more frankly, the host doesn't care. The host really doesn't care about it, but we do as network admins, and you're going to see why in the next couple of videos. Now, let's go down a bit. Now, the term static and dynamic, I want to throw this in now. It refers to how the host is assigned its VLAN membership, not to how the VLAN is actually created. And you're going to see what I'm talking about when we create some VLANs here in the next couple of minutes. And again, whether you're using static or dynamic VLANs, the host itself does not really care what VLAN it's in. But the switch port cares, the switch cares, and we, the network admins, care. Now, I'm going to bring up the live equipment here in a moment, and we're going to take a look first, I believe, at Show VLAN Brief, which is what I have up here for us right now. That's Show VLAN. I want to show you these two commands, and we're going to be running these a lot. And we're on a little 12-port switch here. I'm going to use some different switches throughout the course. And what we're on right now is actually a traditional layer 2 switch. It has 12 ports. I brought the font size up as far as I could, so one of the ports is hiding over there, but it is fast 12. And you can see here again that all of our ports are in VLAN 1 by default. Now, you've got 4 other VLANs here that I would know, 1002 through 1005. These are also default VLANs. We have 5 default VLANs on our switch. these VLANs cannot be deleted. Now, the VLANs 1002 through 1005, they're really legacy VLANs at this point. You know why we say legacy in networking? Because we don't like to say the word old. You may never use these. If you've never touched Token Ring, you didn't miss anything, because as people in my past videos, watch my past videos know, I was never a huge fan of Token Ring configuration. Anyway, you will never use these. That's almost a certainty, but they are on there for legacy purposes. Now again, 1 and 1002 through 1005, those VLANs cannot be deleted. Now, show VLAN is really where you begin any troubleshooting, whether it's on your exam, in your lab, in real-world networking. And you get a lot of information here, though, that frankly you're not going to need to get started with your troubleshooting. And you can see down here again, we've got other columns about remote span VLANs and the VLAN type and the SED and the MTU. This is not information we really need to go into for the CCNP switch exam. It's also not information that you may need for fundamental troubleshooting in your network. So the command I like to get started with is show VLAN brief. And you can see how brief it is. It's only going to show you what your VLANs are on this particular switch, their names, what the status is, and the ports that are in each particular VLAN. And you can see again 12 ports are in there. I would be very familiar with both commands for your exam and your exam prep, but again, show VLAN brief is really the one that you're going to run much more often. Now, there's one more thing here too that I want to mention, and it's about troubleshooting. I actually have a bonus troubleshooting lab, if you will, here for you at the end of the VLAN section, and it's something that came up with when I was working, that I came up as I was working on these other labs for you that we're going to have in the next couple of videos. And you would be surprised how often show VLAN brief can help you solve an issue, because for whatever reason, human nature, whatever you want to call it, we tend to sometimes go for the most exotic solution when we're doing our network troubleshooting, and sometimes it's just the simplest thing. And that's exactly what you're going to see in this particular part of the course in another video. But again, always start your troubleshooting with show VLAN brief or show VLAN. Now, you know, occasionally here an admin will say, you know, well, we don't use VLANs in our network. We don't do that. Well, what they actually mean, of course, is that they haven't configured any other VLANs, but VLANs are still in use. Because again, just one more time, for now, Cisco switch ports are in VLAN 1 by default. Now, each VLAN is its own broadcast domain, which means right now any hosts that I have connected to that switch are in one single broadcast domain. Again, we know what that means. Broadcast comes in, it's going to be flooded out. It's going to be forwarded out every other port on the switch. Now, what we're going to do in our first lab is break that up a little bit. Now, you might want to jot these addresses down, even though I believe they're in every diagram as well, because to meet Cisco's best practices, we're going to use the single IP subnet 10.110/24, and as always in my videos, the host number will also serve as the last octet of the host's IP address. Now, the ping results are going to look a little different because what I'm doing in this lab is using Cisco routers as my host. And here is what we're going to do. It's going to be this simple. We're going to have these addresses 10.1.1.1, 2, 3, and 4 on our 4 hosts. And we're going to have them all in VLAN 1 because that's our default VLAN. Now, one thing I want to mention, and this is excellent prep, excellent knowledge for you when you're working on a lab. Always test your basic connectivity before you start a lab, because you don't want to end up troubleshooting something that you don't really need to troubleshoot. And what I mean by this is, when all 4 of these hosts are in one VLAN, I should not have any trouble sending pings around. And I will do that again off camera here. I'll do them from from host 1 on screen, but you always want to test your connectivity before you start. So we will do that at the beginning of the very next video. We'll dive into this lab and start creating some VLANs a couple of different ways.